All right, guys, so lesson 4.4, we're looking at using the first derivative to find when a function is increasing or decreasing, as well as recognizing the maximum and minimums. So we've already done this a little bit. We've already used the derivative to find a lot of this stuff, but maybe in other contexts. So kind of leading up to this point, we've been taking a function, we find the derivative f prime of x, and we set that equal to 0 because that's where we know we have a slope of 0, which represents maybe a maximum, maybe a minimum. It could also just represent a slope of 0. So maybe it's not a maximum or a minimum. So what we're going to be doing today is a lot of that same stuff, but we're going to look at what's happening in between those critical numbers. We're going to look at what's happening instead of just at the point where it equals 0. We're going to be looking at what's happening to the left and what's happening to the right. So there's some step-by-step instructions here that you are welcome to read through. I'm not going to read through them because that's super boring to listen to me read. So pause the video. You can read through the instructions, kind of the step-by-step stuff, and you can always refer back to it later. Same with this great big paragraph. It talks about when you're writing increasing and decreasing intervals, when to use parentheses, when to use brackets. At the end of the day, it really doesn't matter. Most of the time, you're okay to use either or, except for when you're dealing with infinities. Make sure you use the parentheses. So now that you're back, because you totally paused the video and read through all those instructions, it gives me a function, f of x equals x squared minus 9 to the 2/3, and it wants me to find the interval where this function is increasing. So this function is doing something, right? This function is going up and down. It's increasing, decreasing, all these different things. It wants to know where. It wants to know when is the function going up, when is the function going down, what are all those different, where's that stuff happening, all right? So the procedure, first thing we're going to do is find the derivative. So f prime of x equals 2/3 times x squared minus 9 raised to the what? Negative 1/3. And chain rule, don't forget to multiply by the 2x, the derivative of the inside. So if I clean this up a little bit, I end up with 4 x's on top, and on the bottom, I have 3. And instead of writing the 1/3, I'm going to write it cube roots of x squared minus 9. I think it's a little bit easier to deal with setting things equal to 0 when we have square roots instead of fractional exponents. So here's my derivative, 4x over 3 multiplied by cube root x squared minus 9. Now, I need to look for critical numbers. And remember, critical numbers come from anything that makes the denominator 0. Or I guess anything that breaks the function, or anything that will make the function equal to 0. So in this case, if I plug a 0 in on top, 4 times 0 is 0. So that means that if I plug in a 0, I'm going to get 0. As far as the bottom goes, I'm looking at this square root, and I'm looking at what numbers going into that, or that cube root, excuse me. What numbers going into that would give me 0. So I end up with 0 on the bottom. And if I plug in a negative 3, I get 9 minus 9, which is 0. If I plug in a positive 3, I get 9 minus 9, which is 0. So those are my critical numbers. So I know that at those points, I have a slope of 0. So they could be maximums, they could be minimums. And the attention there is on the word could be. But we do know that that is also where the function could be changing direction. It could be going up before 0 and then start going down after 0. Because the slope becomes 0, we want to know what's happening on each side of those numbers. So the way that we do that, and I know we've done this a little bit, is we like to use a little, it's kind of like a number line. And I always label mine. I'm going to use this line and this is representing f prime, okay? We call this a sign chart, and it just helps me kind of figure out what's happening in the problem. So the first thing I do on my sign chart is I put my critical numbers, 0, -3, +3. Now, I know what's happening at those points. I have a slope of 0. I'm not interested at those points. I'm interested at what's happening in between those points. So, for example, I'm interested what's happening in between 0 and 3. What's happening in between 0 and -3. So at a number like -1. And maybe what's happening at 4 and what's happening at -4. So I pick numbers that are in between these different intervals, and I'm going to use what's called the first derivative test. And all that means is I'm going to pick these numbers that are in between this -4, this -1, this 1, and 4. They're in between my critical numbers, and I'm going to plug those into the first derivative, and I'm going to see what happens. I'm just looking to see is my function increasing or decreasing. So all I need to look at is not necessarily the number itself, but is it a positive number? Because that means my function is increasing. If it's a negative number, that means I have a negative slope and my function is decreasing. So when I plug these numbers in, I'm going to plug in, let's start with an easy one. I'm plugging these into my derivative. So I'm plugging these into this function right here. And if I plug in a +1, I end up with a positive on top, and on the bottom, I end up with a negative. So when I plug in a 1, I get a negative number. I don't care what the number is. I just care that it's negative because that means my function is going down. If I plug in a 4 to this function, I get a 16 on top, so that's positive. On the bottom, I get 16 minus 9, which is 7, and it's not going to be a pretty cube when I take the cube root of it, but all I care about is that it's a +7, which means I have a positive over a positive, so this is going to be a positive number. Going back to now not so pretty numbers, right? Let's plug in a -1. When I plug a -1 into the top, I get a negative. When I plug a -1 into the bottom, I also get a negative. So that means a negative over a negative is going to be some positive number. When I plug in -4, I'm going to take -4, plug it into my derivative. I get a negative on top. On the bottom, I end up with -4 squared, which is 16 minus 9, which is a +7. So I get a positive on the bottom, which means a negative over a positive is a negative value. So that's my first derivative test. It tells me that from -infinity up to the point -3, my function is decreasing. But then from -3 to 0, my function is increasing. From 0 to 3, my function's decreasing. From 3 to infinity, my function is increasing. So let's write that down because I think it wants the increasing and decreasing intervals. So I can say that my function is increasing anywhere I see that plus, right? So it's increasing from -3 up until it gets to 0. And then it's also increasing from +3 up to infinity. Okay. Now my function is decreasing anywhere there's those negatives. So from -infinity up to -3, my function is decreasing. And from 0 to +3, I'm also decreasing. Now this homework also wants you to find what are called the local extrema. So remember in the last homework we looked at, we called them relative or local extrema. So they were maximums and minimums, but they maybe weren't necessarily the absolute maximum. So my function can be going up and down multiple times, right? So these points right here would all be relative maximums because they're the largest number relative to the numbers around them. But only this one up here would be the absolute maximum. Well, today it wants us to find the relative extrema. So it wants me to find the relative maximum and minimum. And again, to do that, I know that I'm going to get a maximum. A relative maximum happens anytime my function is going up and then stops and comes back down. So it happens anywhere that I have a positive slope and then it switches to a negative slope. So when I look at my sine chart, I have a positive slope right here, and then I switch to a negative slope at the point 0. So that means that I might have a maximum at the point, well, I definitely have a relative maximum at the point 0 because I'm switching from a positive to a negative, okay? And it does want the point, so I'm going to have to plug 0 in to my original function. Let's actually plug it in. Whoa, that's a messy. There we go. We got to plug it into our original function. 0 minus 9 is negative 9, and then I have to take it to the 2/3 power. I don't want to do that, so I'm just going to do negative 9 to the 2/3 power. I like calculus. It'll let me do that. So that's my maximum point. That's a relative maximum. I better be careful that I write it that way. It's a relative maximum point. Now to find my relative minimums, those happen anywhere my function is going down, anytime my function is decreasing and it stops and goes back up. So anywhere I go from a negative to a positive, that tells me that I have a relative minimum. So when I look at my cool little sine chart, I have a negative until I get to -3, and then it switches to a positive. So that means that I'm going to have a relative minimum at that point, -3. I also have a negative between 0 and 3, but at the point 3, I switch to a positive slope. So I also have a relative minimum at the point 3. So if I plug those in, these are going to be a little bit nicer because when I plug -3 in, I get -3 squared, which is 9. 9 minus 9 is 0, so that just becomes 0. And when I plug in 3, I'm also going to get 9 minus 9, which 0 to any power is still going to be 0. All right. So this question was asking for the relative max, the relative minimums, and my intervals where I was increasing and decreasing. So these problems aren't, the nice thing about them is they're not difficult, right? The math isn't hard. You take a derivative, you set it equal to 0. The hardest part is sometimes simplifying the derivative to find those critical numbers. But then from there, you're just plugging numbers into equations and looking, and half the time you don't even care about the number. You just want to know, is it a positive or a negative number? All right. So let's look at a couple more examples. I don't know if we're going to do all of these today because that makes for a really long video. In fact, at any point, if you feel like you can handle this, go right ahead and jump in, see what you can do. But we might as well let's do at least a couple more. So number 2, y equals x minus 2 sine of x. And I'm only looking at the interval from 0 to 2 pi because, of course, this function just goes up and down forever. So y prime equals 1 minus 2 cosines of x. All right. Now I want to set that equal to 0 so I can find my critical points. So 1 minus 2 cosine of x means 1 equals 2 cosines of x, which means 1/2 equals the cosine of x. So I want to know, where is my cosine 1/2? And that happens at 2 different places. That's going to happen at pi thirds, and it's going to happen at 5 pi thirds. That's where my cosine is going to be 1/2. So my critical numbers for this problem are x equals pi thirds and 5 pi thirds. So when I make my chart, when I make my little y prime sine chart, it starts at 0. I don't ever go below 0, and I don't ever go above 2 pi. But I'm going to check, I need the point pi thirds, and I need my critical point 5 pi thirds. So I want numbers in between these. And the way that maybe what we should, we might as well. We can just, when I'm looking at these numbers, picking numbers in between these values isn't going to be very pretty. But all I'm really trying to do is find numbers that are in between like 0 and pi thirds. So if I make I'm going to make you bear with me because this is the way my brain works. And if your brain works the same way, great. If I have my unit circle, right? This is the point 0. This is the point pi, or the angle, the pi halves, right? So pi thirds is right here. And at pi thirds, my x value is 1/2. My y value is √3/2. So this interval right here, when I'm going from 0 to pi thirds, I'm starting here and my x value is going over until it hits the point at pi thirds, which is 1/2. Right? So it started out, my maximum point was 1, and it's working its way down to 1/2. So it's getting smaller. And then when I get to pi thirds, it reaches that 1/2, right? So as I'm going along those numbers, when I plug all of those different numbers in, when I plug in all these different values into my function up here, I'm always going to be in between 1/2 and 1. All right. So when I take a number that's in between 1/2 and 1 and I times it by 2, it's always going to be bigger than 1, right? Because 2 times 1/2 is just 1. So everything else bigger than 1/2 is going to be bigger than 1. So when I plug those numbers into my equation, I'm doing 1 minus something bigger than 1, which is going to give me a negative value. Then if I keep going on my unit circle, if I'm going from pi thirds around all the way to 5 pi thirds, which is down here, right? 5 pi thirds is here. All of my numbers, all of my x values are smaller than 1/2, right? I've got an x value of 0, -1/2, -√2/2, -1. All of these values all the way here are smaller than 1/2. So when I times them by 2, I get a number smaller than 1. So that means when I subtract it from 1, I'm going to end up with a positive number. Right now, some of you are like, oh my gosh, this doesn't make sense. Good. We'll show you the number way in a minute. In between 5 pi thirds and 0, my x value is bigger than 1/2, which means when I times it by 2, I'm going to get something bigger. Where's my button? When I times it by 2, I'm going to get something bigger than 1, which means when I subtract it from 1, I'm going to end up with a negative. If you don't like doing that, don't do it. If you don't want to do it that way, then just pick numbers that are in between. So like in between 0 and pi thirds is like pi sixths. You could use that number, plug it into your calculator, find out you get a negative. In between pi thirds and 5 pi thirds, ooh, that's a really easy one. There's a number pi. Plug that in, get an answer. In between 5 pi thirds and 2 pi is going to be what? Like 7 pi fourths? That's in between there, right? It's bigger. Yeah, so 7 pi fourths is in between those. Plug it in your calculator and you get the same answers. The point is, from 0 to pi thirds, I have a negative slope. From pi thirds to 5 pi thirds, I have a positive slope. From 5 pi thirds to 2 pi, I have a negative slope. So my function is decreasing from 0. I can't say negative infinity because I don't go that far. I start at 0. So from 0 to pi thirds, my function is decreasing, and also from 5 pi thirds up to 2 pi. My function is decreasing. I'm increasing from pi thirds up until I get to 5 pi thirds. All right, cool. Now it wants to know my relative maximum and minimum. So remember, and I have to draw this little picture all the time. If I have a negative slope and it turns into a positive slope, like I do right here at pi thirds. I go from a negative to a positive. That's going to be a minimum. If I go from a positive slope to a negative slope, which happens at 5 pi thirds, that's going to be a maximum. So I have a minimum, well, I have a relative minimum at the point pi thirds. Oh, now I have to plug pi thirds into my original function to get my y value. So pi thirds minus 2 times the sine of pi thirds. Pi thirds minus 2 sine of pi thirds. Well, the sine at pi thirds is root 3 over 2. So this we can change to root 3 over 2. And so 2 over 2 cancels. So that's just pi thirds minus root 3. So that's my relative minimum. My relative maximum happens at the point 5 pi thirds. And when I plug that in, I'm going to get 5 pi thirds minus 2 times the sine of pi thirds, which is also root 3 over 2. No, it's not positive root 3 over 2. It's a negative root 3 over 2. So that's going to become a positive. So it's going to be 5 pi thirds plus root, not 2. Come on, read. Plus root 3. Because my y value is negative at 5 pi thirds, right? Because I'm down below the x-axis. Cool. All right, number 3. So trig problems, yeah, those are ugly. Anytime you have to use the unit circle and then plug in all those fun values for x. Good times, good times. Okay, so number 3. Yeah, let's do this one because I think this one's going to end up being a little bit messy of a simplifying problem. So number 3, I'm gonna use some space over here. So for number 3, f prime of x equals, this is a quotient rule problem, right? So on top, I've got to take the derivative of the top, which is 4x cubed, and I've got to times that by the bottom, which is 3x. Then I'm going to subtract the derivative of the bottom. Well, that's easy. That's just 3 times the top, which is x to the 4th plus 3. On the bottom, I get 3. Actually, let's just rewrite it. 3x squared. Isn't that just 9x squared? Yeah. So cleaning this up a little bit, f prime of x is equal to 12x to the 4th minus 3x to the 4th minus 9, all divided by 9x squared, which simplifies to be 9x to the 4th minus 9 over 9x squared. The 9's cancel out, so this simplifies to become x to the 4th minus 1 over x squared. And right here, you want to say, I'm done. But on top, we have a difference of squares on top. So x to the 4th minus 1 can be rewritten as x squared plus 1 times x squared minus 1 over x squared. This is my f prime of x. And it can be rewritten even one more time because x squared minus 1 is also a difference of squares. So I have x squared plus 1, x plus 1, x minus 1, and all of that is over x squared. Okay, so a couple of things I need to look at. First things first, the original equation has an x on the bottom, which gives me a domain restriction. X cannot be 0, right? Because that makes the denominator of my original function 0, and that's not okay. So 0 is not a number. I can't use that as a critical number. It's not in the domain of my function, all right? So when I look at f prime, I'm looking for things that turn... 0 turns the bottom into 0, but it's not in my domain, so I'm not going to worry about the 0 on the bottom. What I want to know is what makes the top 0. Because if the top is 0, then my function is also 0. So What numbers would make the top, I don't mean to write 0 equals, what numbers would make the top 0? Well, x equals 1, if I plugged it in here, that would give me 0. X equals -1, if I plugged it in there, that would also give me 0. So, okay, all right, I feel good about that. So those are my critical numbers. So when I do my number line, or my sign chart, I've got -1, 1, and I also am going to include my domain restriction, because technically it's not a critical number in the sense that it cannot have a maximum or a minimum, right? But at that point, my function can still change direction. My function could be going up and then hit an asymptote, and then on the other side, my function could be going down. So I can't have a maximum or a minimum at 0, but it could be an asymptote. So I'm going to still check what's happening to the left and the right of that number. So this is my f prime sign chart. Let's pick numbers. So something bigger than 1, we can do 2. Something smaller than -1, -2, -0.5, and 1/2. So, man, this problem is going to take up all kinds of space, right? So when I plug in -2, now remember, I am plugging these. Let's get rid of some of this. In fact, there's a lot of stuff going on. So we're going to clean this up just a little bit so it's easier to see what we're doing. There we go. All right, so here's my derivative. I need to plug in -2. When I plug in -2, I get a positive number on the bottom, right? On the top, when I plug in -2, this becomes positive. This becomes, and maybe I should write these down. This is a positive. This is a negative. This is a negative. When those all multiply together, the top is a positive. So a positive over a positive is still a positive. Okay. When I plug in -1, I get a positive on the bottom. On the top, nope, sorry, not -1, -0.5, right? We're plugging in -0.5. So I still get a positive on the bottom. On the top, -1/2, 1/4 plus 1 is a positive. -0.5 plus 1 is a positive. -0.5 minus 1 is a negative. So I end up with a negative over a positive. So this section is actually decreasing. That's a negative. Okay. Now let's plug in positive 1/2. I still get a positive on the bottom. On the top, this is a positive. This is a positive. But this is a negative still. So I get a negative over a positive, which means on both sides of 0, I'm decreasing. So it's like my asymptote, I hit my asymptote, but then on the other side, I'm still decreasing somehow. That's all that means, right? Okay, so let's see what's happening at +2. So at +2, erasing some of my numbers here, I get a positive on the bottom. I get a positive here, a positive here, a positive here, which gives me a positive on top. Positive over positive is a positive. So my function is decreasing anywhere I see those negatives. So it's decreasing from -1 to 0 and from 0 to +1. My function is increasing from -infinity up until I hit -1, and from +1 to +infinity. So that's where I'm increasing, decreasing. So now if I want to look for minimums and maximums, my function is going up. Oh, where's my marker? My function's going up. It hits -1. What are you doing, pen? I'm going up. I hit -1, and I go back down. So that's going to be a maximum right there. Negative, switching to a negative, sign doesn't change, so doesn't matter. Right here, I'm going down. I hit +1, and then I go back up. So right there, I'm going to have a minimum. So I'm going to have a relative maximum at -1, comma, and now the fun part. We get to plug -1 back into the original function. There we go. All right. So when I plug it into the original, I get a negative 3 on the bottom, right? I get negative 3 on the bottom. On the top, I get negative 1 to the fourth, which is positive 1 plus 4. So I get negative 4/3. Okay, I have a relative minimum at the point 1, comma. So if I plug in a positive 1 up here, I get a positive 3 on the bottom, and I still get a 4 on the top. So that just becomes a positive. That wasn't too bad, plugging in the numbers. Okay, so we've got 2 more problems, number 4 and number 5. At this point, if you're ready to start trying homework problems, I know this is dragged on. These are long problems, easy math, long problems. Couple of things I want you to keep in mind. Number 4, be careful. There's a product rule. There's lots of negative signs going on, but you are welcome to try that one on your own. We can go over that one together as a class when I see you on Friday, if you would like to. And same with number 5. Number 5, some interesting things happen in number 5 because you find a critical number that actually isn't a maximum or a minimum because the sign doesn't change direction. Kind of like right here, kind of like my function was going down and then it kept going down. That's going to happen in problem number 5. You're going to find a critical number that is not a maximum or a minimum because that can happen in the world. So give number 4 and 5 a try, and then you've got the homework questions. Lots of practice. This topic is huge, guys. This is one that is going to be tested a lot on the AP test. So make sure that bear with the problems. I know there's a lot of them. There's a lot of them for a reason, and we're going to keep using this a lot of class periods going forward. You'll see this on your homework.